Hello students, welcome back. In this module we are discussing a very important rule, that is L'Hopital's rule, and it is also referred as LH rules. So LH rule, or also called as L'Hopital rule, it says what? Basically this is applicable for the limits which are of the form 0 by 0 and infinity by infinity. What does it mean? If you have a function in which when x is tending towards a constant, and that constant when substituted in the numerator as well as denominator, and the answer which turns out to be of the form 0 by 0 and infinity by infinity, in such case we are using LH rule. What does it say? If you have a function L as limit x is tending towards 0 f of x by g of x, and it is of the form 0 by 0 or infinity by infinity, then I can say that L is equal to limit x is tending towards a g f of x by g of x, which is nothing but limit x is tending towards a f dash of x upon g dash of x, which again can be equal to f dash of a upon g of a. But note this point, g dash of a should not be equal to 0. So you might be thinking, sir, what if it is equal to 0? Yes, here we have another solution. If that g dash of a is equal to 0, in such case it is again of the form 0 by 0 or infinity by infinity. As a result, we have to again repeat the process. That is, we have to differentiate both numerator as well as denominator separately. That is, for LH rule, basically first you have to check whether the given function is of the type 0 by 0 or infinity by infinity. If you check and the function is of a type of them, that is either 0 by 0 or infinity by infinity, then in such case you have to differentiate numerator as well as denominator separately. So this is the first step. In case even after differentiating it for the first time, you see that the equation is again of the form 0 by 0 or infinity by infinity, then in such case we have to again differentiate. So it would be f double dash of x the whole upon g double dash of x. In other words, we can say that L would be, when x is tending towards a, it should be f double dash of x upon g double dash of x. In other words, you are differentiating numerator 2 times, also denominator 2 times. So when x is tending towards a and you put the value of x as a, you will find that you get an equation. But again, make sure g dash of a should not be equal to 0, and also g double dash of a should not be equal to 0. In such case we use LH rule. So here we have a function as cot square x minus 3 the whole upon cosec x minus 2 when x is not equal to pi by 6, and at x equal to pi by 6 function has some value k. We have to find that value k when it is continuous at x equal to pi by 6. My dear students, if a function is continuous at pi by 6, we know that f of pi by 6 would be equal to limit x is tending towards pi by 6 f of x. So k, which would be equal to the limit x is tending towards pi by 6, now f of x is replaced with cot square x minus 3 the whole upon cosec x minus 2. Now cot square pi by 6 is what? 3. Minus 3 would be 0 in the numerator. Cosec pi by 6 is 2, and 2 minus 2 would give me 0. So I have got 0 in the numerator, also 0 in the denominator. So I can say that this function is of a type 0 by 0. And whenever a function is of a type 0 by 0, we use LH rule, or we also say it as L'Hopital rule. So by LH rule, we have to differentiate numerator as well as denominator, but separately. So the values would be limit x is tending towards pi by 6 cot square x. So this is a composite function where f of x is cot x. As a result, it would be 2 into cot x into d by dx of cot x, which would be minus cosec square x. And since 3 is a constant, it would be 0. The whole upon cosec x, whose answer is minus cosec x cot x. So cot x gets cancelled, cosec x and square gets cancelled. So what we have is limit x is tending towards pi by 6, 2 into cosec x. Now in this case, when you put the value of x as pi by 6, we know cosec pi by 6 is plus 2. And hence, the value would be 2 into 2, which is nothing but plus 4. And hence, option C is the correct answer. My dear students, you can expect a problem on LH rule. Now, let's once again have a small revision of this. You have to check if a function is of a type 0 by 0 or infinity by infinity. In case if it is of a type either 0 by 0 or infinity by infinity, we have to use LH rule. It says what? You need to differentiate numerator as well as denominator separately. And once you do that, make sure that the denominator should not be equal to 0. And you have to repeat the process until and unless you get your answer such that denominator should not be equal to 0. You need to practice such kind of problems. Thank you.